You ever stop and wonder what tells the robot that built your car what to do? Or the machine that bottled your drink? Or even what's running the power grid? Well, it's not magic. It's actually a kind of invisible industrial brain that runs almost everything around us. Today, we're going to pull back the curtain on this hidden workhorse, the Programmable Logic Controller, or PLC.
Okay, so to really wrap our heads around this, we got to go back in time. Way back. Before you could just type up some code to control a machine, how did you actually give it instructions? If you needed a motor to start, but only after a safety gate was shut and a button was pressed, how did you make that happen? The answer wasn't code. It was something way more physical.
And to understand this whole breakthrough, we have to land in the U.S. auto industry of the late 1960s. Think about it. Every single year, brand new car models came out. Now that's awesome for us as consumers, right? But for the factories, it was an absolute nightmare. Each new model meant they had to completely re-engineer the entire assembly line. It was a massive, super expensive, and incredibly slow process.
And the heart of that nightmare was this, the relay panel. The entire logic, the entire brain of a machine, every single if this, then that command was physically hardwired together using thousands of these little electromechanical switches called relays. A control system for just one machine could literally take up an entire wall. It was this huge, humming, clicking cabinet of tangled wires that was supposed to be the machine's brain.
And this system was just a mess to deal with. See, relays are mechanical. They have physical parts that click open and shut, which means they wear out and fail all the time. They're also kind of slow. But the biggest headache, by far, was flexibility. If you wanted to change one tiny thing about how the machine worked, you had to get in there and physically unwire and rewire that entire wall. Can you imagine trying to find one little mistake in that mess? It could take days. The auto industry was absolutely desperate for a better way.
And the solution came incredibly fast. In 1968, the idea was put out there, what if we replace that giant wall of wires with a single programmable box? Just 1 year later, the first PLC was actually built. Then, look at this jump. By the late 70s, microprocessors made them way smarter, and by the mid-80s, you could link them all together in a network. In less than 20 years, the industrial brain went from a simple idea to a factory-wide nervous system. Just amazing.
So, what is this thing, officially? Well, the National Electrical Manufacturers Association, or NEMA, came up with a formal definition. It's a bit of a mouthful. A digital operating electronic apparatus which uses a programmable memory for the internal data and program storage of instruction. Yeah, the key words you really want to pull out of that are digital, programmable memory, and control.
So let's put that in much simpler terms. A PLC is basically a specialized, super tough computer that's built to survive on a factory floor. Its whole job is to replace that physical mess of wires with a simple, editable program. So instead of rewiring, you just reprogram. It's an industrial brain that you can teach new tricks without having to perform surgery.
So how does this brain actually think? Well, it runs in a constant, super fast loop called a scan cycle. It's a really simple three-step process. First, it reads all its inputs. It's asking, is this button pushed? Is that sensor tripped? Then, it executes the program. That's the thinking part, where it decides what to do based on those inputs. And finally, it updates all its outputs. It sends out the commands, turn on that motor, switch on that light. This whole loop happens thousands of times every single second. Look, think, act, over and over and over again. Now, not all industrial brains are the same size. PLCs come in two main flavors. You've got your fixed PLCs, which are these compact, all-in-one units. They're perfect for a single, simple machine. And then you have modular PLCs. These are more like building blocks. You start with a central brain, the processor, and then you just add on whatever input and output modules you need. It allows you to build a custom system that's powerful enough to control an entire factory.
And this number, this really puts the scale of these things into perspective. A single large modular PLC system can handle over 8,000 individual inputs and outputs. I mean, think about that. That's like having over 8,000 eyes and 8,000 hands, all being coordinated perfectly by one brain. What a massive leap from that old tangled wall of wires.
So you can imagine, the impact of this shift was an absolute revolution. All of a sudden, productivity just soared because machines could run faster and smarter. Reliability went through the roof because these new PLCs were solid-state electronics, no moving parts to wear out like those old relays. But the real game changer, the killer feature, was flexibility. The ability to just reprogram a machine in a few minutes instead of spending days rewiring it, that changed everything.
So where are these invisible brains hiding out? Honestly, everywhere. They are the backbone of all modern manufacturing. They're in the plants that process your food and bottle your drinks, the power stations that light up your city, the mines that pull materials out of the ground, and the chemical plants that make all sorts of essential products. Pretty much, if it was made by a complex machine, a PLC was almost certainly in charge.
And that brings us to the final thought here. Just look around you right now. Look at your desk, your phone, the building you're in. Nearly every single object in our modern world is the product of some automated process. And right at the heart of that process is the humble PLC, that invisible brain that took us from those messy walls of wires to the efficient, automated world that we all just take for granted.